How's about the next one? Surprise, it's not a place yet. You got to learn a little bit, a tiny smackerel of petroleum geology. Trust me, this is important for some context. Much like the dump site thing, I feel like this gives you some context on what's going to happen, okay? So then, salt domes. What happens? You know about salt. You love it. You know the taste of it. You tell me I'm weird for licking rocks. Well, tell you what. Rocks, minerals, you've tasted it all, baby. We got salt. You love salt. I love salt. So, how do we get salt? Well, typically, you'd have a body of water. Something happens and, body of water dries up. You are left with salt along the remains of what was once a saltwater lake bed, pond, etc., etc. And over time, sediment gets onto it. The salt layers get buried and buried and buried. And then, eventually, something begins to happen. Now, I know there's going to be some confusion about this because of how the word sounds. We're getting to something called diaperism, where you form a diaper. I am enunciating this slowly because if I say it too fast, it sounds like diaperism. Yeah, we're talking about diapers. So, here's the thing. Salt itself is pretty, I want to say geologically speaking, it's very malleable. And what happens is, let me see. Yeah, I think I should have probably done a couple bullet points here. Yeah. So what happens is you've got a body of salt and all the pressure increases, and something's got to give. And the overlying rock strata, they're relatively brittle, so it pops through. Now, it's not a dynamic, but I mean, if you want to think short term or just think of how fast things work geologically, that's what happens. It gets squeezed through and it makes a divide. And that's why you get a dome of sorts. If you want, actually, no, there's still one more bullet point I got here. In the process, this makes a lot of folds and faults. That's going to come in useful in just a little bit. And I think I'm in the way of the final bullet point, but if you need a mental cue of what this looks like, picture the plumes on a lava lamp. That's effectively how this will move and shape and contort itself. Just picture a lava lamp. And those are the shapes that it'll sometimes form into. It may not look as psychedelic, though, I'm afraid. Actually, if you look at it with the right color map on a seismic display, it does look a little trippy because velocities go crazy in the middle of a salt cap. Used to work in a salt mine, got constant battle, would pop the heads off of 4-centimeter steel bolts. Ooh, bitchin'. Let me see here. So, next topic. Still a little bit petroleum geology. Little bit. So I mentioned the salt domes, and I mentioned the faults. I mentioned the folds. That's important because we get into a topic called traps. Petroleum geology is a very complex field. I am skipping over so many little things, okay? So the notion here is a trap is an ideal sweet spot for a reservoir of gas or petroleum to get caught in. So the notion is if you have a salt dome and you do proper exploration, there's a pretty good chance that you're going to have oil in a salt flank. And that's what they will often try to exploit when they're drilling in a case like this, okay? Because getting a reservoir, I'm skipping over so much stuff, but it's very finicky to find an ideal reservoir to drill into. And these make like kind of a Goldilocks sweet spot, if I had to summarize it. You know what I mean? Yeah, so you have a trap, leads to a large reservoir. There's more to it. We'll leave it at that for now. Okay, why is this important? Well, as mentioned, salt domes can have petroleum traps due to the fault and folding, makes them good for exploiting for oil and gas. Okay, the place, Lake Peigneur. Lake Peigneur is a lake, as you may have surmised, It is in southern Louisiana, relatively near the coast. There's a canal that actually feeds from its southern end straight into the Gulf of Mexico. Yeah, I'll throw this onto YouTube. Don't worry about it, Zawala. As for the characteristics, it's about 10 feet deep on average, 2 square miles. That's 3 meters deep, 5.3 square kilometers. Okay? 1980. Not Conoco, I believe it was Texaco. I knew it the other day. Texaco contracted some drilling in the area, and they began drilling in the eastern shallows. Now, I believe if I had to draw it on the map, I believe the point they were at was maybe right about here. Let me switch colors. I believe they were probably right about here, where I've got the red dot. Okay, so that's about what we're looking at. This right here is Jefferson Island. I don't think it'll come up, but it is something that is important to the area. Okay, so morning of November 20th, 1980, the crew begins drilling. Now, they're going. Then about 100 or two, actually several hundred feet earlier than anticipated, they get a lot of resistance. They were like, we should have been hitting the salt strata a ways deeper than this. This is too shallow. Well, we're roughnecks, whatever. We did everything we should have. Keep drilling. They keep on drilling. And this is a 14-inch drill bit. It seizes. And that's not too uncommon. Sometimes these get seized up. It's kind of weird for it to be so shallow, but they're like, well, whatever. But they cannot get it unstuck. It's the damnedest thing. Then, I have never heard confirmation on where this was from or what it was, but they heard a loud popping noise. I want to say this was probably their machinery. Probably. And the platform begins to do a big lean. So what they decide to do is they were keeping it tethered in place with barges. They cut their barges and they get the hell off and they get to the shoreline. Okay? Let me resituate something. I think that's right. No, I sniped myself. Wow, look at that. Okay. Lake's haunted, yep. Well, 1,300 feet or 400 meters below the surface. Meanwhile, there's an electrician in a mine. Here's something weird. He's like, what's all that noise down the corridor? Decides to go take a little trump. What mine? Did you skip something? Oh, I forgot. This was right beside a 60-year-old salt mine. Okay? What happened is the drill bit popped through the roof in one of the massive corridors. Okay? These are big corridors. This isn't like, oh yeah, it's a person tall or something. If you ever looked at salt mining, they have massive pieces of machinery just tearing through shit. There is so much space. So, what happened is the electrician was hearing banging. He goes down and he finds several empty metal drums are hitting against each other. And that's because water was pouring out of the ceiling and flooding shit. So he goes over, hits the alarm, and thankfully everybody got out. There were 60 miners, they all got out, and it was one of those funny things where apparently it was an elevator that can, as happens with this, it's an elevator that can only hold a couple people. So they were just slowly getting people out, just like, oh God. Finally get out. Now, pause. How did this happen? What's going on? So something to get out of the way. This isn't something like, oh, we didn't know there was a mine there. They did know there was a mine there. Information is fed to these people on a, they were told specifically where to drill, okay? And I will have a drawing I will need to do in a moment or two. So here's the thing. This is where I need to pull up Photoshop, I think. Actually, probably not. Not for now. So from interviews I had seen, the way they decide where this is placed is they are told effectively, you need to drill at this location. To find this location, you need to find the triangulation of 3 points. Now, from what I had heard, let me see. I want to do this tool, I think. Typically, it's like, I'm doing this super piss easy. I've got somewhere straight north. I've got somewhere straight south. I've got somewhere straight east. Now, the notion with this was well before GPS. Guys like this wouldn't have GPS till like the late 90s, early aughts that would work decently. This was they told them, I read about this being triangulation. The way that I surmised this would be done is they would have some sort of a compass. Like what I had in college and did field work with was a Brunton compass. So they probably told them, okay, there is one structure. You need to have that at 0 degrees or 360. There's another structure. You're going to want that at 180. There's a third structure. You're going to want that at 90 degrees. So they know where these 3 points intersect. If you've got all of those angles set, that is where you drill. Now, from what I have heard, I don't know if it was the drillers who were at fault or the people who told them they were at fault. But one of these locations, they were either told the wrong azimuth or they measured it incorrectly. And that totally screwed with the placement of where they needed to be. In fact, let me see. If I were in charge of the drill, I'd simply not drill anywhere near the mine. Could we just look for oil elsewhere? So, the fact that remember I said they hit the salt very early. That's because they were so off the mark that they were actually hitting the salt at a totally different place and angle. In fact, the borehole, they should have been drilling 400 feet away from where they were drilling. And instead, well, they drilled super far away. And in fact, they pierced straight into these lower strata you see down here. Engineering ethics. It's field methods, you know. You learn this stuff. So, it's just a small lake. It's just a small lake. You could just let it drain, right? Well, we're getting into problems. Down the drain. So, back to our story. We have unpaused. They've popped a hole into one of the deeper levels of the salt mine. And it was now just spraying water at like orders of magnitude stronger than a fire hydrant. It is insane, the amount of pressure. Yeah. So, the lake bed sediment, water, everything, they were going down the drain. There was like an actual whirlpool. There were landslides. Things were getting sucked into it. There was a big, huge vortex. In fact, on the lake, there were 11 barges and a tugboat. They got pulled under. Now, this was something I was kind of curious about. I was like, how big is a barge again? Well, according to Google, a barge is usually around 200 feet long, 35 feet wide. If that is accurate, 11 of these big, huge suckers got sucked down. They were gone, brother. That's big. So, landslides surrounding the shore, everything begins to fall in. This chimney you see here, the water level rose around it. This used to be 30 feet lower. I believe this is a chimney that was like on the second floor of a building. And you can see right here, it is right up to this. This is like the big one they always point to say, yeah, it was 30 feet lower than this before this all happened. And you may be sort of like, wait, the water got sucked into a hole. Why are we looking at a lake that still exists? Well, there's one other thing that happens because of this. There's more? Yes, there's more. I mentioned a canal that went to the Gulf of Mexico. It's called the Del Cam Canal. Flows out into the Gulf of Mexico. The water level in here dropped, and there was suction coming from the vortex. For an extended period of time, the canal reversed direction. The Gulf of Mexico was flowing inward. And also, for a while, Louisiana had a 150-foot waterfall. That's what this is a picture of. That is how big of a problem this is. This is not an arbitrary place. This is along the coast of Louisiana. That is not supposed to happen. No. So, begins to pour in, continues eroding the salt dome more and more and more. Also, because of the amount of water coming in, there was actually an explosion of compressed air out of the mine. Like it was just a deafening boom of compressed air. And then not long after, a 400-foot geyser shot out of the mine shaft. This was a little bit of a fucky-wucky. There may have been a few things going wrong on this day of days, right? 9 days later, the water finally stopped. Oh, the barges, those 11 barges that got pulled under, 2 of them never came back. 9 of them bobbed up like metal corks, as I saw described a few times. But yeah. Before we get to the field trip, you have any questions? There may be a review of the lake that is very interesting / scary that I saw. Feeling salty after that? Well, it already was a saltwater lake, so concerns? Let me see. The destruction of metal supports. It's interesting. Did the oil company pay any penalties for this? It did. I think it paid something to the salt mine, but everybody in the salt mine lost their jobs and they were not really given any sort of benefits or anything. They were just effectively told, sorry, somebody fucked up the entire salt dome. We're going to fire you all. We can't reimburse you. So, yeah. It was fresh water before the disaster. Oh, my mistake. Interesting. Huh. Yeah, it's unfortunately about what you'd expect, you know? I didn't realize it was fresh water beforehand, huh? At least your one stopped. So, let me see. Chrome, do I have this up already? I don't, I'm still on Centralia. So let me get the link actually ready. Share embed, copy link. Okay. So, Chrome, let me dunk this in here. There we go. Not too much we can look at on this guy, but here's Lake Peigneur today. The Del Cam Canal goes down here, and it eventually gets to, yeah, the bay, what the hell bay? Vermilion Bay, that's what it was. That's kind of the route it goes. But let me see. Here we go. This is something that was interesting. This guy says, I took my little boat here with Navionics app and Wi-Fi sonar, mapped the hole's depth over several hours of grid search pattern, 5 miles per hour. The lake is mostly 2 to 3 deep, and I must admit this uneasy feeling when I watched the sonar drop suddenly to 115 feet. Also indicated huge fish lurking in the hole. You can see the result, yada, yada, yada. Yeah, the huge fish in the hole. I wonder if that's the barge, but probably not. It's probably changed because of just I mean the local wildlife got totally flipped on its head. So anyway, super short on this guy. Super short on this guy. Nice catfish hole. Yeah, buddy. Yeah, buddy. Just don't go too deep, right? El Gigante. Okay. Shark sucked in the lake. Wow. They're really buckled down, huh?